Okay, I'm happy because I have a whole bunch of goodies here. And I'm always happy when there's a whole bunch of goodies to show. Okay, so like Jeanette said, I was here. I was telling Mark yesterday, it was 5 years ago, and then he and Josh were like, I think it was more like seven years ago. And then last night I was like, well, I better check. And I checked, and it was 9 years ago that I was actually teaching there. And I can't believe how time flies. And I think that this program started 10 years ago, right?
9.
Huh?
Just before you came.
Just before I came. So I taught the second cohort. I taught the Building Virtual Worlds course. And it was awesome. It was a great experience. And we did a lot of really cool projects. I created this thing. I worked with one of the students, and we built from scratch. We built an entire virtual world, on-around world that had gravity everywhere. And one of our projects was to use the roundness of the world for your project, for your virtual world, which was really fun. One team built a game where you fly and you just establish orbit, and that's part of the game. And I was like, yes, my physics works. And it was written in Java, when Java was different than it is now. And so that was really fun and exciting. So it's really great to be back, and of course to be staying in the new building and to be part of this all. So I've pieced this out into 4 sections: on life, bodies, and intelligence, on the evolution of animated characters, on biodiversity and social diversity, and the connections, on reality, augmented and otherwise. Now, are these little swim bots going to be too distracting while I'm talking? No, you guys are good at not being distracted, or being distracted, as it were. So, I want to start with a question. Intelligence has a body, yes or no? Yes. Who says yes? Who says no? Interesting. Okay. If I ask it a different way, intelligence requires a body. Yes? No? Interesting. Okay. I'm assuming that the no's are wrong and that the yeses are right, because then the next question is, what is the body of artificial intelligence?
Computer.
You think? When I was at MIT in the 90s, good old-fashioned AI was still happening, but that was changing. People at MIT and Carnegie Mellon were getting onto the artificial life bandwagon. They were starting to say, okay, look, this whole AI thing is not working out. We're not getting the human intelligence that everybody said we were going to get. Why? Maybe it's because the symbolic logic and the language and the various things that these AI researchers are trying to replicate only represents a small sliver of what intelligence really is. It's that part of the front part of the neocortex that humans are good at, that humans have, and that doesn't exist very much in the lower animals or anywhere else. The artificial life researchers were like, okay, look, if we really want to understand intelligence and if we want to replicate and create a new intelligence, we need to go deeper into the biosphere to what creates this intelligence at the final end of this long emergent process where there are many layers of emergence in between. And that's very interesting if you're fascinated with biology and if you're interested in emergence in general. And I think many artists and technologists are interested in emergence whether they know it or not, because things come out of a process that didn't exist before. So emergence is a really big part of artificial life, and it's a big part of the work that I've been doing for pretty much all of my career. The second time I came back to Vancouver, I worked at SEAT over there in Surrey. And we did a project which I called the gestural Turing test. And I published a paper along with Maggie Seif El Nasser and Bardi Akabegi and Richard Overington, who was the guy in charge of the motion capture studio at Emily Carr. And that's where we did this research. We went to the motion capture studio at Emily Carr. How many of you have been there? Have you seen it? I don't know, it was kind of exclusive then. I don't know if it still is, but it wasn't being used very much. So we had the joy of being able to go in this giant Vicom studio and playing around with their motion capture. And what the gestural Turing test is how many of you know about the Turing test? You have to know about it if you're working with computers. The Turing test is basically Alan Turing's thought experiment. Somebody asked him, how can we make intelligent machines? And something like, well, I don't know, but we can make a machine that does something that fools us into thinking it's intelligent. And maybe that's enough. Because after all, I can't say for sure whether you're alive and real, but you look like you are and you act like you are, and that's good enough. I can't go inside of your brain and ask you how it's working. But the problem with the Turing test is that it's based on text. It's disembodied. It's based on words and sentences, language that is asynchronous. Real living things live in space and time. We are embedded. We are embodied. And that's the kind of intelligence, and that's the kind of simulation of intelligence and understanding of intelligence that we in the artificial life world want to pay attention to and use. And so the gestural Turing test uses points of light that are put on motion capture markers of the head and the hands of the subject who is trying to convince the person on the other side of the screen that it's a human. And we wrote software to imitate that. And it was a really interesting, we published a paper and it was presented at a conference in Toronto about how we were sort of doing a variation of the Turing test. Now, the gestural Turing test was one piece of a larger scope of work which I was doing while I was in Vancouver, and that was a book, which I finished when I was in Vancouver. And this book encompasses a lot of the thoughts and experiments and ideas that I had formulated while I was working in Silicon Valley in virtual world companies. So one of those companies was there.com, and I co-founded that along with Will Harvey. And then I was there for 6.5 years. And then I joined Second Life. I joined Linden Lab, makers of Second Life. And in both companies, I was developing avatar expression systems. And if you spend almost 10 years building avatar systems, thinking about how to make that avatar puppeteer your expressions remotely, you get into some really deep questions about body language, about how we communicate real time online. And it makes you think a lot about what's happening to us when we're face to face and how that's different than being remote. So avatar puppeteering is a very interesting question. And here's the book. I would encourage you to look at it. There's a whole blog that has lots of articles that are based on the chapters in the book. But this is continuing on with this theme of embodied intelligence and how it blends in with our own intelligence and how we puppeteer ourselves over the internet. So the internet is our medium for body language. Now, with that in mind, with the considerations of embodied intelligence and embodied AI, let's look at the evolution of animated characters. This is Gene Pool, which the first version of this I wrote when I was at Rocket Science Games. Anybody heard of Rocket Science Games? Probably not. You know about Rocket Science Games. And of course, Nuala knows about Rocket Science Games. Rocket Science Games was in the 90s. It was one of those bubble companies. And it was, they called it Sillywood because it was Silicon Valley meets Hollywood. They were trying to blend the Hollywood model of production with games. And it was kind of a failure. Because it's very hard to mix film, a linear medium, with all its production approaches, with computer games, which is a nonlinear interactive medium. It's a very hard collusion. And it's still hard, right? It's still hard to combine the linear medium of film. And I was at Digital Hollywood. I did a presentation there. And people are having the same debates. How can we get our films working in virtual reality? Really hard question. Because filmmakers spend so much energy getting you to look here and there and pay attention to the right parts of the cinematic experience. And if you turn and look over there, you've ruined it, right? So virtual reality is very problematic in that sense. Anyway, I'm getting off track. Let me tell you about Gene Pool. The way this works is, and now I get to show you off the awesome technology that Mark has helped set up with Apple TV. Isn't this just the most awesome thing in the world? I'm just like drunk with happiness here. So with this app, these characters are simple shapes. They're like little machines. I call them swim bots. And they're like little abstract shapes that you would see in a Miro painting. But unlike those shapes, wow, these guys have been evolving for a long time while we've been setting up here. Let me see if I can find an interesting you know what, I'm gonna do this. I'm gonna start with a new population here and randomize it, because it's really fun to see how this whole thing starts off. So this is a Darwinian simulation. These shapes, they move by sine wave functions, and they all, each swimbot has different parameters that cause them to move in these different ways. And there's a simple physics simulation which is causing them to be propelled through this two-dimensional water. And they each have a desire. There are two goals in life: to mate and to eat. It's kind of like real life in some way. But since they're born with random genes, the majority of them will not be. This character is awesome. I've never seen that swimming behavior. But see the little white arrow there? Yeah. That's its love arrow. It wants to mate with this weird thing over here. But it's having a hard time getting there. Why? Because this creature was not given genes that make it swim. The population needs to evolve to earn that ability to swim. And Richard Dawkins wrote a book called The Selfish Gene. How many of you read the book? Okay, not enough of you. And in that book, Richard Dawkins says, I want to see a simulation that really truly simulates Darwinian evolution, not just the lockstep genetic algorithm where whump every, oh, did it happen? Oh my God, we got little babies here. Ooh, this one's kind of all tweaked out now. Now it's hungry. Right? One feature that I never got to add is like lights a cigarette afterwards. But I guess cigarettes are, maybe it vapes. I don't know what's the latest. But so Richard Dawkins says, I want to see a simulation that actually reproduces Darwinian evolution. In Darwinian evolution, the definition of fitness is you have offspring. That's it. Darwin evolution doesn't say how, why, how you do it, but you just have to have offspring, because then that offspring inherits your genes. And by virtue of the fact that the swimbot was able to get to its mate, something about that fact means that swimbot was a better swimmer. Maybe. It's all statistics. So if I were to keep this running for several hours or a day, most of these would be gone. They'd die off, and you'd have some really great swimmers. And they evolve. They were not told how to do it. So they're self-animated in a sense. Let's see, we can look at the most prolific. Wow, there's a lot going on there. It's like a neighborhood in San Francisco. So most prolific means how many had the most babies. Now, interestingly, most energy efficient is not necessarily the best swimmer. The most energy efficient means it's got this nice, sinuous, eel-like motion, but it doesn't necessarily turn on a dime and get to a mate or food that it's chasing or whatever. So this is really a fun kind of starting point for a lot of the work that I've done in the years that followed. So let's just let that continue to run, and we will see. Here's mutual love, by the way. Got to show you that. Mutual love is where the camera zooms into two swim bots that want each other. And usually they can't get each other, so it's like so many movies that we see. So let's just keep that running, and I will then show you some other cool stuff. So looking at the evolution of animated characters, let's go way back to the first examples of art, if you can call it art. I'm not sure if you want to call this art. The user cave paintings. And people have commented on these cave paintings as these animals are kind of animated because they're running and these primitive humans are chasing them and trying to eat them. But to really look at the evolution of animated characters, let's zoom up to the 20th century, to the age of cinema. And in the age of cinema, a new technology and a new art form were born. The technology was cell animation, and the new art form was cell animation. Not a big coincidence, because oftentimes when a new technology is born, a new art form comes along with it. I'm not sure what comes first. I think usually the technology comes first, and then once that technology is settled and people have learned how to express with it, a new art form is born. The age of cinema gave birth to animated characters. And that turned into the evil empire, depending on your point of view. During that time, television came along. Television was a real-time medium, broadcasting real-time. Here's the newscaster telling the news of the day, seconds before you see it. And the Muppets were the perfect kind of animated character. And they are real-time animated characters because they're animated by real humans who put their hands up their butts and make them puppeteer them. Interestingly, Muppets came around in around 1960, and that's when I was born. And my mother made Muppets for us, me and my three siblings, out of foam rubber and felt. She was a seamstress. And so we would help make these Muppets, and we would play with them. And it was a really formative time for us. My brother used to do cartoon characters, and I followed suit and did some cartoon characters. And we would put on these puppet shows. We'd put on these puppet shows for Mom and Dad, and it was really fun. I had a ventriloquist doll. Actually, I had several ventriloquist dolls because every Christmas I would have destroyed the ventriloquist doll, and Santa Claus would have to get me another one. So that was Jerry, and I used to draw pictures of Jerry. Then when I was in college, I would deconstruct Jerry in every way I could. And also in art school, I was making characters out of clay, exploring the different shapes and stuff. And this is all kind of the primordial stuff of the Wiglets, which I'll show you in a minute. This guy's wearing a Syracuse University cap. And also when I was playing with photography, I was really interested in the animation of the animals and capturing them in motion. This is probably inspired by that famous Salvador Dali photograph, you know, with the cats in the water. One of my favorite photographs in the world. This cat was not happy about this photo session. And the old Italian lady whose house I was subletting wasn't there. Believe me, she would not have been happy with this photo session. Anyway, so the Muppets became a big thing with the Children's Television Workshop and Sesame Street and everything. And through many negotiations, the Muppets became assimilated into the evil empire. So we have the age of cinema and the age of television. Two technology ages and two ages in which certain art forms have come into being. But television is so yesterday, right? We have mobile computing, we have AI, we have augmented reality and virtual reality coming into being, and geolocated and data-driven and all of that stuff. So the question is, who will invent the Muppets of the mobile age? I think it's time to have a new kind of animated character. Because right now, animated characters are pretty linear, even in games. They're kind of linear. I would like to have an animated character that looks at me at the same time that I'm looking at it. And I mean really looking at me. I don't mean just the animator made it look at where the camera is. A character that's truly data-driven, that's driven by physics, AI, and genetics, can mate and have offspring, just like real animals. Wouldn't that be an interesting kind of animated character? And which brings up some of the biological questions about diversity. So which toy do you think has been loved the most? Interesting question, huh? Because here we've got this beautiful, handsome, perfect Disney doll, and then we've got this thing which is falling apart. But I imagine that the little girl or the little boy had hugged this teddy bear for years and years, and its eyes are falling off and all that. But that teddy bear has probably been loved a lot. It's very imperfect. And this imperfection is kind of related to diversity and uniqueness in some of the many ugly animals that I love so dearly. I don't even know what the hell that is. I think that's some kind of toad or something. But isn't it cool? Isn't it just fun to see these? I mean, how can Darwinian evolution produce these freaks? And during the Cambrian evolution, the Cambrian explosion, as they call it, is one of the errors in early evolution, when the genetic code kind of went and all of a sudden it was able to do all this amazing stuff. Creatures with limbs coming out of their whatevers. And most of them died off, right, like these guys. But that burst of creativity created so much amazing diversity, which is still with us now. Didn't they just discover a dinosaur fossil whose mouth was like this? You seen that article? Yeah, they discovered some weird dinosaur that had a crazy mouth. Like, why? How would that survive, and why? Survive enough to give us a fossil now. But this uniqueness and biodiversity can translate to social diversity because, you know, we love the Pokemon characters and all of the varieties, and we can identify this one with this one and that one. But imagine being able to identify with a character because you've bred that character through several generations. Now let's talk about augmented reality, where I think things are going to get really interesting. Do you want to go back? Oh yeah, thank you, sir. What's the purpose of augmented reality? Why do augmented reality? And we'll get into virtual reality in a bit, which is closely related, obviously. Well, according to Magic Leap, if you follow this video, you'll get a certain sense of what it's about. Let's look at this video. How many of you have seen this video? A lot of you have seen it. Okay, you get the point. That's very awesome technology, and the guys who make Magic Leap are down in Florida, and the main game designer, whose name is Graham Devine, was one of the backers of my Kickstarter campaign, actually. He only gave me like $30. I was hoping that he would kick in like $500K or something like that, being at Magic Leap. I mean, after all, Magic Leap got a $500 million investment from Google, right? And since then, they've gotten billions more. So they're estimated to be worth billions and billions of dollars. But I think that shooting robots that splatter blood on your glasses, and that's getting kind of old. So now, I believe they made a new video. I saw a new video that they made recently. And how many of you have seen the latest video from Magic Leap? They're showing more of this cool interface stuff where you can do your email and things like that, which is very interesting. And it looks like they might be shooting for that, although they've shown lots of videos of whales jumping out of gymnasium floors for some reason, and micro elephants that emerge from your hands without gravity, whatever that means. But anyway, so it's an awesome, cool technology, and I don't think they know or care about the content as much as this awesome technology, which is going to be a game changer. I'm more interested in the content of augmented reality, because not a lot of people are figuring that out yet, I think. So here's my version. It's a view into another dimension. What was that?
Boop.
It's a self-animated character, or you can think of it as a self-animated Muppet.
Look, Daddy, I made a flower graph.
I think of them as little machines that have forces that are pushing them and pulling them in different ways, which is very different than traditional animation. So there are no poses, there are no keyframes here. They behave differently every time you see them. And that makes them more alive.
Pomegranates are here. So I'm gonna hit them, okay? All right, watch me hit them. Oh, I'm sorry, Backpack, I hit you instead.
So she'll look at us while we're reading and she'll go, well, what do you think? You know, she'll have this body language like I know you're there and I know you're reading this book, and would you hurry up and turn the page? Virtual reality is all about immersing yourself into another reality. And it's very much escapist for a lot of people. Augmented reality is about the real world with a layer on top of it. So by having these creatures out in the real world, it encourages kids to go out into nature.
Really cool shapes, but they seem to get excited when... Oh man, I think I had two guys make an offspring, or a couple.
If you've got two wiglets there, you can combine their genes to create a new wiglet. Once you've grown that wiglet, if you like that wiglet, you can drop it somewhere else in the world. So we become the agents, we, the owners of wiglets, become the agents of their evolution. With the genetic database of these creatures and their locations and their personalities and their histories, you could layer all kinds of games on top of that.
But that one's yours, the purple flower. That's
And
really...
this one.
What I'm interested in is what is the content that we're engaging with? What is that virtual content that's overlaid on top of the natural world? That's what we're focusing on right now. The technology is going to change all the time.
Picnic.
To get kids and adults alike engaged in the real world, in the locations in which they live, is important right now, bringing us back into locality, which the internet took away from us. That's a certain take on augmented reality and what we can do with it. And so, like I said, these are self-animated characters, and they're intended for augmented reality. They're intended to be self-animated, alive, semi-intelligent, and geolocated. And they come to life as soon as the software starts running. They were not made in animation studios. And my good friend Alan Sperling, who used to work at Pixar, who worked on Toy Story, he, he's appropriately kind of nervous about the new kinds of animated characters and all the physics and all the AI that's coming in and gradually nibbling away at the animator's craft. Although I don't think the animator's craft will ever go away. It'll just get shifted on to different places, just like what always happens when Maya and Max and these things acquire these new tools that take the place of some of the physics and some of the tools. Some of you guys have been in the animation industry for a long time, so I'd love to hear what you think about that. So DC Spenceley calls it Facebox, because the Oculus is now owned by Facebook. And I don't know if I want this to be our future. I mean, not that people are going to be walking around with boxes in front of their faces and bumping into each other, but hey, the porn industry is going to love this, right? They probably already are. But more interesting to me personally is augmented reality, because we're all about connecting with each other and connecting with the world, not necessarily living inside of a hallucination. Augmented reality can make the invisible visible. How many biology teachers would love to be able to show leaves to their students and have them put on their augmented reality glasses and see photosynthesis happen before their eyes, to see the molecules interacting, to make the invisible visible? And of course, with geolocation, with geolocated augmented reality, your connection to that real thing is located in a certain place. So place becomes a big part of that, and that has big implications for gaming. Interestingly, I made this slide a long time ago, and I saw this beautiful fish. Is that a salmon? Do you know if that's a salmon? It's not a salmon.
That's a bass or something.
A bass. Okay, it's a bass, yeah. I don't fish, so I don't. Salmon tastes better than bass. But after I saw that, I met Esteban, and he said, hey, come down and check out this painting that I'm doing down in the hangar. And we looked at it, and I took a photograph of it, and I did a little photoshopping of it. And there it is. This is actually big. It's actually like, I don't know, like as big as this wall, right? And he's drawn it, he's gonna have kids paint it in instead of him painting it. But the interesting thing is we had a conversation about augmented reality. How could we use augmented reality to make this an educational experience? So you don't just look around and see these interesting scenes where the toxic waste comes out here and the trees are collecting fresh air there or whatever, but you can look at it and get little narratives that pop out as you look at it in different parts, and we could even craft it so that the narration goes in a certain direction or a certain order. And then if you zoom back and look at the whole thing with your augmented reality device, you might see an entirely new piece of content. So in a way, augmented reality can take static, two-dimensional art and dimensionalize it in a big way. So with this idea of learning about biology and self-animated characters, we did a Kickstarter campaign. And at first I was like, okay, let's try to get $20,000. And my colleague Barry, who built a lot of the underlying Objective-C code to get these apps done, said, no, let's go lower. I'm like, lower? But we need the money to pay for all this shit. And he said, no, Barry has backed more than 100 Kickstarter campaigns. I mean, every day there's a box that shows up. It's like, oh, it's for Barry. Yeah, it's for Barry. What is it? I don't know. He gets Christmas presents every week. It's a Kickstarter. It's not a Kickstarter campaign. Sometimes he gets it a year later after the Kickstarter campaign was done, which if any of you have had experience. And being on the other side of the equation now, I know that it's really hard to get things out on time. So anyway, we got funded. We got our 15K. And that evaporated in about 3 weeks. Right, Nuala? It was like, gone. Some of that. Anyway, we got written up in Boing Boing and a bunch of other things. And of course, you know, when you're doing a Kickstarter campaign, you want to try to get written up, and then you want to like show everybody that got written up, and you want to kind of like fluff it up as much as possible or as soon as possible within the span of a month. During the Kickstarter campaign, we were building prototypes of this thing and showing it to kids. And one kid, she kept putting her hand in front of the marker, right? And I was like, stop that, you're not supposed to do that. You're blocking the camera's view. She wasn't listening to me. She just kept putting her hand in, and she started to pick up the character and move it away because it was all about her and that character. She had an emotional bond with that character. She didn't care about the technology. Next thing you know, she's carrying this character around, and we're like, how'd you do that? Wait a minute, we didn't write the code to do that. And she's like, whatever, you know, that's her character. She had discovered this feature in the software called extended tracking, which is a feature that you can turn on or off in the Vuforia plugin. And extended tracking, in fact, we were just looking at that earlier. Maybe I can show that in a little while. But extended tracking basically says if the computer vision software is looking at an image and using that to track the content, if something gets in the way, extended tracking says, okay, I've lost part of the image, but there's something else here. Let's hang on to that. And then if you move that, your content moves along with it. It's really amazing. It's where augmented reality is going. Because right now, augmented reality, at least the marker-based stuff, you need a two-dimensional image with fairly good contrast so that the computer vision software can hang on to that. But the way it's going is that would be with SLAM, S-L-A-M, simultaneous location and modeling. I believe that's what it stands for. Where you pick up your iPad and you look into the room and you move it around, and the parallax of the motion of the camera picks up the three-dimensionality of things in the room, and it starts to build a model of the room, and might even bring textures in as well. And that becomes the backdrop, a three-dimensional modeled backdrop instead of just a flat image. Anyway, so this little kid copied me onto this fact, which is awesome. Okay, so now it's time for me to take off my shirt, and the reason is, and don't worry, I'm just going to stop at this shirt, because one of our Kickstarter rewards is a t-shirt. Yeah, well, there's nothing fancy about that. People do t-shirts all the time with Kickstarter. But this t-shirt has an augmented reality marker on it. Let's see if we can get this working. Thank you, Mark. And this took quite a bit of fiddling to get this right, because you know, an augmented reality marker wants to be flat and stable. It doesn't want to have wrinkles, and it doesn't want to have boobs getting in the way, you know, things like that. So, so with this app, we had two t-shirts, one with flowers, one with bird poop. And we have this little selfie mode. There she is. Now, see how she's kind of jumping around and kind of losing track? That's because, you know, I'm moving and this is not a flat surface and everything, but it's remarkably good considering. I don't think anybody else has done this, and also it's difficult to get these designs on a t-shirt because most t-shirt manufacturing labs have a silk screening process, or even if it's digital, they don't usually do the shoulder. Hey, Peck, gravity, hello. But okay, so there's another feature here with this app. We created these greeting cards, which were also Kickstarter campaigns for the backers who couldn't come up with more than $5. And with this little card, we have these characters. And this one's very pitiful. Let's get rid of that one. That one's not so good either. Oh, that one's even worse. Oh dear, you're sad. Oh, come on, you guys. Whoa. Now, this whole tap dancing thing was never intended, but the physics algorithm that makes them walk, let me see if I can. There we go. Well, now it's more interesting. your butt. Where are your eyes? Okay, then we've got this app, which is a little less weird. Oh, there's the extended tracking. Isn't that cool? Here's Peck Peck. She's our feisty little mascot, and she always wants to do right. Yeah? What else do you have to say, Peck Peck? You want some seeds? Want another seed? Now, let's see if she looks at us. Hey, Peck Peck, look at us. Hey, come on. Peck Peck. I think she just wants to eat food. What we really wanted to do was make a book, an augmented reality book. But one of the first things we did, we went to the bookstore and we started looking at Dr. Seuss books and asking ourselves, wouldn't it be cool if you opened up this Dr. Seuss book and out pops the Lorax in augmented reality? And these wiglets are already very Seussian, right, to begin with. Just add a little extra Seussian appendages and they're Dr. Seuss characters. And we thought, wouldn't it be cool to approach Random House publishers and say, hey, how would you like to sell more of your Dr. Seuss books? We have an app that'll help you do that. And then we decided that we wanted to explore making a book that's specifically about augmented reality, where the content of the book, the actual book is a stage, and the characters are the actors. And instead of using existing content, we would generate it from scratch. So all of the textures and images and plants and everything in here are from our local environment in Petaluma, California. And the story takes place in the ancient valley of Petaluma, where Peck Peck is born. And we wanted to kind of tell a little nonverbal story. And we had lots of debates, me and the team, about whether to have words in the book. Some people who were on our team have had experience making children's books. And the basic story is a lot of people want to make a children's book, and very few people are really good at it. So we decided not to try to do that, because that would be really, really hard. So we made it a nonverbal book, and let me show you that now. Okay. Thank you, Mark. Hello, everybody. Hi, Peck Peck. Yes, hi. Where are you going, Peck Peck? Yeah? What are you telling us? Ah, looks like she went into the book. So here's, I'm sorry I'm so shaky here. There's a butterfly made out of leaves. And let's move over to this page. So here's where Peck Peck is born. Sorry, here's where Peck Peck is born. Now notice that this is 2D. I was inspired by The Wizard of Oz, where the first part of the film is in black and white, and then it becomes color when she lands in the land of Oz. And similarly, in the beginning of the book, when things are not so great, it's a 2D story. So this is all 2D. I actually did the math to make this content flat. And because it's inherently 3D content, I decided that it would be easier to just squash everything in Z. That's what's going on here. Right? So isn't that cool? It's kind of like it's like the book is animated. It's cool in a different way than 3D. So here's that thing. You saw a little piece of this. You saw a little piece of this in the film. Yeah? Okay, and then the story unfolds, and then Peck Peck comes along and she meets this weird guy in the puddle. And that's actually a screenshot of Monsanto Corporation. Off in the distance. It literally is Monsanto. And in this story, Monsanto was responsible for all of the magenta-colored toxic genetic pollution. And this guy Sombrero, he's got a really big belly full of beer or something, but you know. And then later on in the book, we get to the three-dimensional scene. And here's where they meet the poop monster. And then I'll just rush off to the end of the book where Peck Peck loses her friend Sombrero, and she's kind of sad, but then she reaches the end of the book where things are very lush, and everything's better, and everybody lives happily ever after. So it's a prototype for a new kind of book, and the idea being that this is a stage. And check this out. The book, you pay for the book. You can go to the Wiggle Planet website and pay for the book. The app is free. But the idea, some of the ideas that people have been kicking around is that as an in-app purchase, you can buy a new version of the app. And with the same book, you see the same story, but a new character pops up sometime in the book, and the story changes. So you could have the same book and a different story every month. In fact, one of these characters could be like, it's getting to be about 10 o'clock. I got to go to bed now. So if you happen to be looking at the book at 10 o'clock, this character's just going to climb under a tree and fall asleep. So you can have different things happening at different times, and geolocation. If you're in Rio, you might have a different experience than if you were in Oslo. So it's a prototype for a new kind of storytelling, where the characters are more like actors than animated characters. And let's see here. There's a Hungarian entrepreneur, I'm not going to try to say his name, who he and I have been in touch recently, and he said, I was asking him if he remembers me showing him the stuff. He says, yeah, I remember very well. This just underlines how kinetic characteristics reinforce memory. Remembering, and I was like, cool, the hippocampus is running really well, because the hippocampus takes memory and it takes space, and it combines spatial reasoning and memory, and of course I've become fascinated with the homunculi in the brain and the cerebellum and all the various parts of our brain that make for embodied intelligence. And I think these characters, what I'm trying to do with these characters is make them bodily intelligent to make them non-verbally intelligent. Social and emotional intelligence is much more interesting to me than being able to play chess or parse a sentence. Or at least it can be the beginnings of that kind of emergence of intelligence. So, to conclude, I think that augmented reality characters with embodied intelligence can help us become more connected to the environment as well as to ourselves. And that's it.